Hello, this is just a real quick review of the homework that the teacher gave out today. Just because you're not going to have time to get feedback from the teacher for doing these homework questions. So we just need to go over these really fast so you're super prepared for the test. Okay, so 670, number 8, classify the solid. Number 8 is obviously a sphere. Number 9, you count the number of edges here, and there are 6. So, and it's a pyramid because there's a point on the top, so it's a hexagonal pyramid. Number 10, count the number of faces, edges, and vertices in the solid in exercise 9. We sort of did that, but reviewing it will never hurt. Because it's a 6-sided polygon, there are 6 triangles, so that makes it 6 faces there plus the base, so that's 7 faces. Edges, those are the lines. There are 6 lines in the hexagon, and there are 6 poles going up in this little tent type thing, so that would be 12. 6 plus 6 makes 12. Vertices, there are 6 in this hexagon and 1 on top, so that makes 7. The base of this is a question, and this is a general question that she probably is not going to give you, but just in case, we'll just go through this incredibly quickly. This is a general question. If you have an n-sided prism, which means you have a polygon on the top and a polygon on the bottom of n sides each, how many faces do you have? Well, you have basically how many walls do you have? You'll have n walls, and then you'll have a top and a bottom. So a top and a bottom, so that makes n plus 2. The answer is n plus 2. In terms of the edges, an n-sided polygon will have n edges on the bottom, and then you'll have n edges on the top, and then you'll have n poles. So the answer with that one would be 3n. Vertices. How many vertices does an n-sided polygon have? How many corners does an n-sided polygon have? An n-sided polygon has n corners on the bottom and n corners on the top. So that makes it 2n. This is a question where the answer is general. She never really gives these types of questions on the test, but just in case, that's how that problem is done. Okay, now we're moving right along to 13 and 15. She said she wasn't going to ask you to actually draw these solids, only draw views. So that brings us right to 17. Sketch the top, side, and front views of the hexagonal prism. So looking at this thing, this step 3 thing, looking at it from the top, it's obviously a hexagon, right? You're looking at it from the top, you see a hexagon. Looking at it from the side, it's actually, this shape is very, very reminiscent of what's called a bay window. Okay, if you go on the internet and search for a bay window, they have them a lot in San Francisco, California. Like every house in San Francisco has a bay window. And if you look at a bay window from the side or from the front, basically from either way, you basically see 3 rectangles that make up a big rectangle. So obviously this, we're not talking about this thing, right? This is a mistake, right? Right. So the answer to number 3 in terms of the side view of a bay window is a rectangle that looks like this. And from the front view, looking at it this way, it's the same thing. If you're not quite sure, go on the internet under bay window and you'll see exactly what a bay window looks like from the front view. Okay, so that does that. Now we'll go on to, that would be, now we go on to page, this one, page 621. These problems are very, very clear. It's just using the formula, so we've already done these. We've done so many of these that these things are coming out of our heads. So there's no need to do those right now because those are just formulas. Same thing for number 23. But number 25 has a special twist to it. It has some algebra on it that we just need to go over because if she gives it to you, you want to get it right. Okay, so I'm going to make it much easier. Those numbers there are weird, and they'll give, like, unless you have a calculator, those numbers are weird to work with. So let's work with a trapezoid that has an area of 100, and you know the formula, 1/2 of the area, right, is equal to 1/2 the height, which in this point will give it a 10, and the sum of the bases, which will say 5 plus b1. Okay, fine. So now that's a very similar problem. You'll get the same type of question, same type of formula if you do number 25. Now what do you do here? You do 100 is equal to 5 times, is that right? 5, yeah, 5 times, and then 5 plus b1. Okay, so the problem is, how do you solve for b1? You can't just subtract 5 from both sides because this 5 is bothering this term, right? The 5, you really want to knock the 5 out. Okay, so how do you knock the 5 out? You want to knock the 5 out by dividing both sides by 5. So we want to change this to a pencil, right? And we want to divide this side by 5 and this side by 5. If we do that, we take these two 5s, we knock them out, and then we're left with 5 plus b1. And here we're left with a 20. So let me try to draw that, even though it looks very primitive. We get the point, right? And then this is 5 plus b1. Now it's really easy to solve for b1, right? We can just switch back to pen and pencil here, or actual letters. We do 20 is equal to 5 plus b1. And obviously you subtract a 5 from both sides, right? And then b1 is equal to 15. And that's the answer. Obviously it's in inches, right? Because it's distance. So that's how you do this problem. So if you have a problem like this and you have to solve for this poor b1, this poor base that's sort of like floating in the middle of nowhere, right over there, it's like by itself here, you have to get that, whatever's multiplying these parentheses, you have to get rid of it by dividing both sides by that number. Okay, so that's how you do this problem. Okay, so just be ready for that one. That's the hardest algebra you will see on the test, but you are now ready for it. Okay, now Emily's reported that the teacher gave out this stuff today. This is not going to be on the test. I can't believe she's going to put this on, but just also this is just helps you for the homework for today, and also at some point you'll need to know. But let's go over it right now very quickly, just in case it is on the test. How do you do the stuff? Volume. Okay, volume. How do you do volume? Volume. You find the area of the base and you multiply by the depth. The area of the base multiplied by the depth. So the base here is 6 times 6. You multiply by the depth times 6 times 6. So it's 6 times 6 times 6. Here the area of the base is 4 times 17 times 4. Sorry, the area of this base is 7 times 14. Okay, so whatever that is, and then you multiply by the depth. Here you can also call it the depth, 8. So it's 7 times 14 times 8. Here, what do you do when it's not a rectangle? You calculate the area of the base. What you do is you turn this thing. This is a tricky way to draw it. You turn this thing sideways. You put the triangle thing on the downside. You know, we can actually rotate it, right? Maybe? I don't know. Can we do that? Nah, maybe not. But you want to imagine taking this thing and turning it on its side so that the base is this triangle. This is the base, and you multiply by the depth. So we need to find the area of the base, which is 6 times 8, which is 48, divided by 2, which is 24, and it's 24 times 14. So you calculate the area. This one's more clear. You count the base is a 6 by 6 is a right triangle. See that little thing that gives it away that it's a right triangle? You need to know that. See that little thingy there that says, I'm a right triangle, I'm a right triangle. So then you do the base times the height of the right triangle, 6 times 6, which is 36, divided by 2, which you get 18. 18 times the depth is 12, so that's how you calculate the volume. Now, surface area, again, surface area is sort of related to what you're doing on the test. With surface area, you just calculate the surface of every face. So these are sort of a pain to do. You have to calculate the surface area of, let's say, this side here, which is 6 times 10. Let's make this bigger. It'd be 6 times 10. No, it'd be 6 times 20. So you got 120 there, right? But then you have 2 of these, so you got 120 on the other side. So you got 120 plus 120 makes 240. Let me write that down somewhere. Okay, so you got a 240. Got it? Now, you've got these faces. This is a 4 by 6, right? 4 by 6. So 4 by 6 means the area of this thing is 24, but there are 2 of them, so you got a 48. Just doing this off camera, as they say. So now we did these faces and this face. Now we have to do the top. The top, let's think about this. The top is 20 by 4, right? 20 by 4. So that's 80, and 80 plus 80 is 160. So you add up 240, 160, and 48. So that's 400 plus 48 is 448, just like it is there, and units of square yards. So to calculate the surface area of these things, you have to calculate the surface area of every face, right? Every face. But it turns out you only have to calculate 3 faces, because then you multiply each face by 2. Because you know this face and the back face are the same, this side face and this side face are the same, and the bottom face and the top face are the same. So you only have to calculate the square area of one of those faces, and you multiply by 2. So that's how you do this. It's not going to be on the test. You're definitely going to have to know how to do it. You're definitely going to have to know how to do it to do the homework that was given out today and the worksheet that you were given out today. So it's not a waste of time to talk about how to do it if it wasn't explained clearly. So that's how you do this thing. Okay? Okay, good luck tomorrow. Just take your time, check the work, make sure you got the formulas right, and you should be fine. Okay, see you later. Bye-bye.